Good evening, everybody, and a massive welcome to STACS Virtual Festival 2024. My name's Debbie Kennedy, and I'm a CS teacher at St Kentigern's Academy in West Lothian, and hosting me this evening is the fabulous Brenda McCart. And I believe we've got another 3 great sessions for you all this evening, and I cannot believe as well that it's the final day, but we are finishing very strong. And then next up is Derek Harris and Rose Kennedy, and they're going to be exploring the new Computing Technologies NPA, which we're all excited is coming out, and that's due to be published, I believe, very soon. Yeah, so you might know that today is National Thank a Teacher Day. So on behalf of everybody working on the STACS project, we would like to take this opportunity to say a Yota bite-sized thank you to all of you, the teachers who provide safe learning opportunities for all the young folk all over Scotland. So special thanks to those of you who are in single person CS departments especially. Thank you to early years teachers, thank you to primary teachers, secondary teachers, and not to forget all of our NQTs and probationer teachers. Thank you all so very much.
And just to emphasise that we are absolutely delighted to bring a very special message from Pam Duncan Clancy, MSP, who's the Shadow Cabinet Education Secretary with the Scottish Parliament.
So we showed this on day 1 and 2, so I hope that if you have seen this before, you will enjoy seeing Pam's contribution today, giving everybody the chance to hear it.
My name is Pam Duncan Glancy and I'm the Shadow Cabinet Secretary for Education representing Scottish Labour. I'm delighted to be able to speak with you, if not in person but virtually today, to first of all say thank you for everything that you are doing to promote the study of computing science in our schools and beyond. We need more support for computing science teachers, we need more computing science teachers, and we need an understanding all the way through the school system, from arguably early years all the way through to the end of high school and beyond into college and university, so that people understand why computing science is important, not just for computing science's sake, but actually for the sake of building our future economy and facing the challenges that we have as a society, both in terms of health and social care and indeed climate change. That's why I'm really passionate about ensuring we've got a strong focus on computing science in schools, more teachers to support the development of that in schools, and an understanding and inspiration for young people in our schools so that they can see the value in computing science for them. I think it's also important to mention that we need to do that particularly with attention to girls and women, because we know that we need to address some of the gender imbalances in this too, and the work that you guys are doing on a daily basis to try and do that is commendable. So I want to say thank you. We in Scottish Labour value your profession, and we value your passion and commitment, and indeed we share it to promote computing science as a subject and as a career in Scotland going forward. Thank you.
Hi, can I ask, can you guys hear me now? First. The audio wasn't working, is it working now?
It's fine. It's been fine for me, Brendan.
Just waiting for that feed to come through. Crackle.
Is it?
I don't know what's going wrong. Folks, we'll just type. We'll try and persevere. I'm really sorry about that. I'm not sure what's going wrong. I am unmuted. Okay, maybe I think it's yours.
Right, I'll continue. Thank you. Right, so let's now welcome Jonathan and Talha. They are both working in the School of Computing Science at the University of Glasgow. As you all know, STACS has its official office in the school, so massive shout out to Quinton and Muffy for giving STACS a home there.
Hi Jonathan, and hi Talha.
We can hear you.
I'm not
I guess I'll start, then I'll move on to Talha. So I'm a lecturer in computing science at the University of Glasgow. My background is in AI, artificial intelligence, and in robotics. So that's the angle I'm taking there. What we are presenting today is a platform, an educational platform that we are currently developing. It's work in progress. And Talha is going to do the presentation today. Is a PhD student that is working on that platform for education. Talha, do you want to?
Yeah, thank you, Jonathan. As Jonathan said, we study at the University of Glasgow. I study.
I think we couldn't understand what Brendan just said. Maybe we could on your side. You know, feedback. I'm assuming that we now have developed So I'm assuming it's all about the talk. I don't know if you can hear me. I'm assuming people can hear so we should start the slides.
I should start. Okay, I understand that I should start. Nothing more. Okay then. Let me share my screen. Can you see my screen right now? Yes. Okay, thank you. Hello again, everyone. As Jonathan said, I am a PhD student at the University of Glasgow, and we are currently work on machine learning and AI education. Actually, my profession is especially on university level education for AI and machine learning, but after we realized the need and interest in the school level, also we decided to present Curio to you, to the teachers as well. So okay, I will just start by showing you Curio, what does it look like, and it will make you know something more about it, and I will show you a few features of Curio after that. Let's watch it together. As you can see, Curio is not too complex. It is just two-wheeled robot, and it can carry a smartphone on it. And the idea behind of it is using a smartphone or any other mobile device to control the robot. As I said, our initial opinion was using Curio on university level, and that's why we focused on AI education especially. For now, you might wonder what is about AI in this video, but I will show you some projects later. And in computer science education, as you know, teaching abstract concepts is usually the hardest part of teaching programming, and people usually use tangible things like robots to make students more motivated in computing science. And we also tried the same thing to motivate people to learn AI and machine learning. In our design, we use the smartphone as smartphones as the brain of our robot, and we don't have any other computers, any other processors in this robot. We just have two wheels and two stepper motors to drive it, a balance ball in front of it to make it balanced, and a battery, and a phone stand, and as you can see, a Bluetooth module to connect to robot, our devices, our smartphones or laptops, whatever you want. And it is wooden. And it makes the robot very cheap and affordable. So why we wanted to create a robot like Curio? Because first, it's affordable. Second, it doesn't need any installation or these kind of things. And it is easy to share your projects, your products with others with Curio. So as you can see here, this table shows you some similar robots, some similar platforms. Maybe some of you familiar with some of these robots. AE robots, AE robots, Daran, Deep Racer, maybe from Amazon. It is very famous one, and many other robots like DuckyBot or OpenBot. But as you can see, almost all of them have higher prices. Maybe this one has $20 price or this one $50, but they don't have enough capabilities to use them for AI or machine learning. But Curio can be used for AI or machine learning education, and it only costs $40 to produce it. Actually, it is not a commercial product for now, but to produce it, to make it possible, it is enough to use $40. And it doesn't need any installations. What does it mean? Actually, if you want to use a robot with your computer, you first need to install many different software, many different tools, and you probably need to know at least a basic level programming information, programming knowledge. But to use Curio, actually, it is enough to have a device which has a capability of running a browser like Chrome or Safari, whatever you want, and has a Bluetooth feature. With this device, you can easily use the Curio robot by connecting it via Bluetooth, and it just communicates with Bluetooth to drive the stepper motors, and you can move your robot. And using a web-based technology, it brings you a few more advantages like ease of share. Nowadays, it is very easy to deploy some web applications, some web pages online without any cost with like Vercel or GitHub page or something like that. And when you deploy a web page, it is very easy to share your web page, with a QR code or just copying the URL. It is easy to share with others. Yeah, that's why Curio is very easy to share and you don't need any installation. And after these technical backgrounds, actually, maybe these were a bit boring for you. I would like to show you a few projects with Curio we have done previously or currently developing. Here we have two projects. One of them is joystick project and the other one is teleoperation. These two projects just created to see Curio's controllability and stability, or maybe connectivity. It is just a joystick application, as you can see, and you can control Curio robot with it. As you can see, it's a web page, a browser open on an Android phone, and you can drive Curio easily. And with this one of the smartphones is mounted on Curio, and one of the other smartphones can drive the robot by communicating Bluetooth and internet to stream the video. And someone else maybe from another room, from another place, you can drive the Curio. As I said, these are just some projects to test Curio's controllability. And we have some maybe AI-related fundamentals of AI projects as well. It is a previous version of Curio, and as you can see, it's a line-following robot. It works autonomously, no one controls it, and it just follows the line using the smartphone's camera and processors. As same, we have an object tracking project here, and when you show an object to the robot, to the smartphone camera, it just follows it. These are the fundamental applications with AI. Who wants to learn AI starts with these kind of projects at first. And that's why these are also very suitable for children level as well. And another project is face tracking, similar to the object tracking project. With this project, the user just shows herself to the phone camera, and the phone and robot just follows her, as you can see. These projects created by the university students in previous years, by the way, and this one is created last summer by a master student as well. It is also can be related with AI because it converts your speech to text first, like your commands to go straight, turn right, or turn left, this kind of, and it sends these commands to Curio, and Curio just moves with this voice-controlled commands. And yeah, another project, it is also from last summer, and students from Singapore just developed these projects in 2 or 3 weeks. They mounted a pen on the robot, and they implemented a Python interface in it. Normally, it works with JavaScript, but they implemented a Python interface on it. And this web page is kind of education platform for students who want to learn Python. They are just using some Python commands to draw some shapes, and in this way they also learn Python. For example, if their task is drawing a star with the robot, they just need to combine the needed Python codes in here, and when they run it, Curio draws a star, for example. And another project is about AI again. With this project, you can train your data set whatever you want, using whatever you want, what object you want. For example, in this one, I used my face to train a data set, an image data set. And after that, when I, for example, look up, the robot goes forward, and when I turn right, it turns also right, or this kind of things. You can use your fingers, you can use any other object on the room, and you can train a data set, train a model, and you can use it to drive Curio robots. Yeah, actually, we are showing you these projects, but these projects are not projects for education. These projects are just examples that you can create, what you can create with Curio. As our backgrounds are not education, we are just creating the tool. We are just trying to develop the tool and make the tool better for education. And we want to leave the rest to the professionals of the education area. So it can be used for any kind of AI education, as you can see. We also, as I said, at first initially we wanted to develop this platform for a university level, but last summer we attended Glasgow Science Festival with this robot, and also we realized that children also love this robot. Children like to use this robot. Probably it is like a car and they can drive it, but we can use, or educators can use this motivational aspect of this robot to teach the children robotics, AI, or maybe just programming. And also, this year, actually next year, we are planning to use Curio in a course at the University of Glasgow. It's a robotics foundations course. Currently, they are using a simulation-based Baxter robot, because even the university can have only one Baxter robot, because it is very expensive and it is very hard to, it's not easy to use it actually. That's why students need to learn the foundations of robotics with simulation. It, of course, caused some problems like limited physical access to a real robot and some loss of motivation. Next year, we are planning to integrate Curio in the curriculum of this course, and in this way, we are planning to catch the one robot per student ratio. And we believe that it will increase the motivation of students on robotics, and they will also help the success of students in robotics course. And yeah, I'm coming to final of my slides, but we have also good news, because we are currently developing a second version of Curio. In the second version of Curio, different from the previous one, we are using wider wheels, as you can see, and instead stepper motors, we are using DC motors, which are faster, and also when you bring speed in action, it is also more fun. And we have motor sensors in it. It is a bit technical aspect, and we are planning to put some LEDs and bumpers at the front of the robot to make it more fun, and to use the bumpers to use them for object avoidance or these kind of things. It will help the smartphone to understand the environment actually, and it will have more compact design. And in this way, we are planning to decrease the costs for assembling, and it will probably decrease the cost of robot even less than $40. It is not exact yet, but our estimations are there. And you will be able to send this robot to anyone in just an envelope, like you are sending a letter. You can just put it in an envelope, and you will be able to send it to anyone. And currently, as I said before, it supports JavaScript applications, but we are planning to bring Python support in action, and in this way, in the field, actually, Python is more demanded programming language, and we believe that bringing Python in action make it more accessible for everyone. And yeah, that's all from me today. You can learn more on trycurio.com. Actually, probably you will learn many things because I couldn't explain you everything about it right now. And whatever you want to ask to me, you can get in touch with me with this email. And yeah, that's all. Do you want to add something, Jonathan?
No, I'm not. I think you come out of the thing. I think you never put it to place it as a product or like that. So that I get to take it. And I need to share it because I think it's done well. Students that are developing in the room, that can share links to it. Those students can find it on their own platform. That's like what campaigns and that's the way that you want to do it. Platform is still work in progress, and as you see, you don't have the curriculum activities you are developing. However, that is for the website. However, you are able to collaborate and work if you are able to be a training one, how to do the technical platform in the one
Hi, Jonathan. Just to say that the sound went bad again there, so we're not really sure what's causing it. Can we just all try and make sure if you're not talking that mics are off, please? Sorry about that. Right, so just like to say, guys, that was actually amazing. That's such a novel way to provide young people with hands-on experience of machine learning and AI. And what I particularly liked about it was the fact that with the speech recognition, you're talking about, level 1, and then with the introduction of Python and the introduction of the JavaScript, you're going right up to level 4. So you could easily use that through all years. It's absolutely fantastic. And just wondering if anybody has got any questions. Oh, brilliant one. Could it be trained to respond to British?
Yeah, actually, we have done a workshop previously, and also it was a suggestion for us to use it for British Sign Language, and yeah, it can be done. As I said, we just focus on developing a robust and easy to use platform for everyone, and we want everyone to contribute on it to create some fantastic projects.
to do the design, they need just to give them quickly and with some design model that can code in a sign language, and that could be some other course that a student could do to overall conducting a seminar, and that will be relatively straightforward to work with.
So just want to say, guys, again, thank you so very much for your presentation. And as it's only a week to go, please have a fantastic summer holiday when it comes. Thank you so much.
Thank you.
Right. So just before we move on to the second session, just a wee reminder to please post questions. And as soon as you post them, we'll be able to display them at the end of the presentations. So we'll select whatever ones come up and we'll get the answers to them as soon as we can. So I believe that now we're going to move on to our second session this evening, and like to welcome both Derek and Ross. So hi guys, welcome to the STACS Virtual Festival. So glad that you are both here.
Thank you very much.
And I hear that you are coming all the way from Dumfries and Galloway.
We are the far-flung distance of Dumfries and Galloway here.
This random fact here, I used to live in a street called Nith Lane, and nobody had a clue what the Nith meant, how to spell it, or what it was all about.
The River Nith, famous
exactly. River. Right, so over to you guys. Thank you so much for coming tonight.
Thank you. Okay, thanks very much for attending the session tonight. My name is Derek Harris, and above me on my screen is Ross Kennedy. And today we are going to talk to you about the National Progression Award of Computing Technology. Before we start, I should say the qualification has not yet been published. However, I would like to bring to your attention that the units have been validated, but the course award has not yet been validated, but that should be done very soon. Okay, a wee bit of background around why this course came around. Both myself and Ross, myself to start with, because Ross is actually a background in physics to start with. Once the new national qualifications come in, I noticed a decrease in the numbers in my current school. I went from 2 classes of 20 down to a class of National 4, 5 and 6 with 7 kids in it. So we found at that point I looked for a need for a course that provided a smoother transition into different kinds of computing backgrounds. And the one I looked at to start with was cybersecurity. And looking at that course, it was really it was a really very good course. It was enjoyable for the pupils to do, but again, it was quite narrow. It looked as if it was just going down one route, and we felt that we needed a course that had multiple routes and encompassed all or a lot of the computing areas. Looking at the national again, we could say that there was a lot of programming within that, and it wasn't anything to do with let's take programming out. It was just to make it a bit more fair weighted within the curriculum. And I also felt there was a need for the gender imbalance was starting to appear again with the computing science qualification. Ross then decided to become dual qualified. We both actually worked at Douglas Stewart High School in Dumfries and Galloway, and we introduced HNC computing because we saw that as a way to provide pupils with qualifications that interested them and qualifications that they felt would be valued by employers. But the problem with the HNC was that it wasn't for everybody, and it was at a level 7, which was advanced higher, so it didn't meet the needs of all our pupils. So what we really wanted to do was revitalise the curriculum and provide a course that would give a smoother transition into the HNC. That grew arms and legs a wee bit because we approached SQA and asked them if we could bring something to the table in terms of a new qualification and a new course. Again, excuse me, provided positive pathways from the junior phase all the way through into S6, and that was really important for us so that we could have that continuation all the way up to S6 and then also into modern apprenticeships and employment. We are from a rural background, and there was a lot of interest from, computing companies that work down here. in terms of what we were teaching within the curriculum, because a lot of kids were moving down to Glasgow or moving to the cities, and they would like to have kept some homegrown talent. So I think Ross will talk a bit more about that later on. Also, we made sure that what we were looking at matched up with the Woods report. Now that's an older report, but now the Hayward report also brings in that idea that our learners should have more vocational courses, more chances for apprenticeships and modern apprenticeships.
So that's the background of where this came from originally. And as Derek mentioned there, we put together a proposal which was taken to the SQA, and this is the basis of that proposal, the brief that we wanted to achieve with this new qualification. First thing is we absolutely wanted it to be a recognised group award, so that it was considered valuable by parents, pupils, school leaders, other partners, employers, etc. Because whilst we totally appreciate you could go down different units and use the range of existing units that are there, we felt that parents, particularly parents, wouldn't see that as a recognised award. So we wanted this new award that was recognised by all. Originally, we wanted to use existing SQA units, but as the development of this qualification has gone along, we have actually introduced new units, and new units have been created. We wanted it to be 24 credit points, and again, that was particularly important because we wanted it to be seen as the same value as a national qualification, which a lot of NPAs are 18 credits. So again, that was a little bit different for this qualification, going in there at 24 credit points. Probably most importantly, we wanted it to be a broad qualification that covered a variety of aspects of computing, including hardware, networking, and programming, amongst other stuff as well. And actually, as the development of this has gone on, it's been nice to see lots of other things come into it, which we hadn't considered at the beginning, and really reinforcing that idea of computing is this broad subject and can go down lots of different routes. It was also important that it could be delivered in schools, colleges, centres with the resources they have, with existing resources. Certain qualifications, Derek and I were chatting earlier about the NPA cybersecurity, which some schools have struggled to deliver because of the resources required to do that. So we were keen to have options for schools and centres to go down certain routes of practical and do more specialist things, but we didn't want it to be a requirement. We wanted it to be open to all, and sort of easy to get on board with. We were talking about progression into HNC computing, just because we wanted to keep it broad. But actually, the way the qualification has come out, it provides pathways into lots of different routes. And the next slide, we go into a little bit more detail on possible progression pathways. Again, really important, we wanted it offered at levels 4, 5, and 6. And actually, Derek will maybe touch on this more when we talk about the sort of consultation process, but there was appetite there for level 3, although currently it's only level 4, 5, and 6 that has been developed. We wanted it to be ready to deliver from now, well, from August. And so despite it not being published quite yet, we're still on track, as far as I'm aware, that for delivery in 24-25. So that's good. Here is an example progression pathway. And as I say, because of the broad nature of the qualification, there is loads of different progression pathways. So this is just very much an example. So offering in S4, NPA Computing Technologies at levels 4 or 5, and then from there, potentially progressing into HNC computing in across 2 years, part-time across 2 years, S5 and S6. And whether that's delivered in school, Derek and I delivered that in school, but in my current school, we also have links with the college where our pupils can do HNC computing over 2 years through College Academy. Then, or another potential option is to progress on to level 5 or 6 in S5, or go down another NPA route, specialise in cyber or games development or whatever might be of interest. This just gives them a broad foundation that allows learners to go on and pursue their interests and go in lots and lots of different routes. And then post-school, whether leaving at the end of S4, S5 or S6, that allows them to go on and study at college, HNC, HND, potentially straight into employment, or into higher education through the university route.
Okay, so once we'd taken that proposal to SQA, I had the opportunity to be the lead developer on this. So we had to provide our due diligence on whether this course was viable. So a number of interviews and research had to be undertaken, and it was quite a vast process, should I say, to try and get a wide range of people to interview. And as you can see there, we interviewed people from STACS. I'm clearly not going to go into names here, but certainly their backgrounds. We had 2 people from Skills Development Scotland who inputted quite greatly into the award, what they would like to see within it. We spoke to a number of head teachers as well, who were also computer qualified. We also looked at our teachers that are doing the bread and butter of the day. SQA managers were involved. We had somebody from a multinational IT company which employ over 4,000 IT specialists. We had an MSP from the Scottish Government there and a former HMI inspector. So we had a good wide range of people that were inputting into this qualification and what they would like to have seen within that qualification. They were all given the same questions, so that we could compare and create a very statistical, quantifiable outtake from that outlook. We then passed that over to the teachers for the research, and the survey had 273 responses. And incredibly, speaking to SQA, that is the largest response survey to a new qualification that they had or they've had, which says that underneath. There was a clear need within that survey for a new qualification. And throughout it, identified that they wanted to see less programming within it. They didn't say they didn't want any programming, and I must stress that this isn't a qualification for just getting rid of programming. It's not that at all. There is programming in the mandatory units, but it's of a proportion that we felt was acceptable, and it was opposite from the new national qualification that was currently there in terms of being a wider, broad-based qualification, and everybody noted that from the research. Ross will put up the qualification framework next, but what I would like to say about that qualification framework is that the 9 optional units, or the optional units, should I say, were taken from the responses of the teachers. So we've certainly listened to them. So they are the top 9 responses from the teachers.
So probably the bit you're most interested in is what is actually in the qualification. So we have taken a similar structure to the HNC in this idea of having optional units to allow for sort of personalisation and to suit the learner, suit the centre, that sort of thing. So the qualification is made up of 2 mandatory units and 2 optional units. So mandatory units, obviously everybody does those. Computing foundation, an introductory unit to get that sort of foundation knowledge, and we'll go into more detail on what's involved there. And a computing project, which will likely take place towards the end of the course, bringing skills together. And then we have this list of 9 optional units, of which you would choose 2. And so this leaves it entirely open to go down whatever route you wish, which is a real benefit. You can see there that there are some existing units. You'll also notice some of these units are taken from other NPAs, so there's potential crossover if you're already offering NPAs, the likes of esports, cyber, that sort of thing. There's also some new units in there, particularly artificial intelligence and emerging digital technologies, which offer something entirely new and right up to date, which pupils are sort of really engaged with.
Thank you. Okay. So we've got 2 mandatory units. That also came from the feedback and through the interview that people would like to see a qualification that gave options for both teachers and also our students. The 2 mandatory units within the framework provide all learners with the same foundational knowledge of computing. And it was an opportunity for us to develop meta skills, which was high in SDS, Skills Development Scotland's agenda. So as I said, we've tried to take everybody's needs into consideration here. The optional 2 units within the framework again provides centres design course around available resources. Ross already hit on that. So there may be some centres out there that are rich with hardware and the physical components, which can do a lot of practical elements of the course. However, we also wanted to make the course available to centres which didn't have or weren't as fortunate to have the physical resources, so they could do a more practical, a more theory-based approach to this course. It also allowed opportunities to customise the course for local employers, and again, I think I touched on that earlier. We have local employers who are looking for networkers and hardware designers, and what they were finding was a lot of those students ended up in universities in Glasgow and didn't come back to the area. So with the companies that we're working with, some of them have offered the provision that we would have apprenticeships for our students as long as we brought them out with the qualifications or the practical skills that they need. Again, what was good was there was an opportunity for teaching staff to focus in areas of their expertise also, which we felt was very important to enthuse those pupils into different areas of computing, clearly alongside the pupil voice aspect of where they would like to go also. And it gives that personalisation and choice for the learners throughout their course qualification. And I'd like to also point out, when Ross went through the framework, each one of those optional units is available at level 4, 5 and 6. So I think that's a good personalisation and choice for the learners. Maybe moving on to different years. So in 4th year they may choose some of the options and may go back to choose another few of the options, whether they were successful or unsuccessful or not.
I'll just jump in there because I see a comment. Optional units will be really beneficial in tailoring to local needs. And so when I joined my current school, Dalbeattie High School, they didn't offer computing at all. And so it was a case of reintroducing computing science. And I remember going to a local employer, ETB Technologies, and first of all, they were surprised, shocked that the local high school didn't offer computing, and they were like, well, that kind of explains why we struggle to recruit local young people. Very pleased to hear that that we were going to be reintroducing it. And when I started talking through the national qualification, they were like, yeah, that's great, but what about this? What about the hardware? What about they work with servers and do a lot of networking work, and so they were like, that's missing. And again, that allows us, that optional framework allows us to sort of work with our local employers and say, well, if you need people who can refurbish servers, then we can do the hardware unit. You can come in, you can work with the learners and really tailor it to suit local employers and that local need. Just to go into, we don't want to go into all of the optional units in detail because they won't be relevant to everybody, but we do want to pick up on the 2 mandatory units because everybody will be doing those. So Derek, if you want to go through computing foundations.
Yep. So computing foundations really is an introductory unit to give learners a broad overview of computing, and that was done deliberately. And again, that's why it's called computing foundations. We wanted to give a good foundation, a theory-based foundation for all our learners. Looking at hardware and systems, we've got software in there as well, and there was a real pull when we decided that we were going to introduce software in it. I think software had to be in it, but it was how we made that accessible for all. The current course, the national courses, have students writing code blindly in exams, etc. I remember when it first came out, with having to really learn Haggis as well as a pseudocode for them. We wanted to introduce software and have a basis for that, so kids not actually, or our learners, should I say, not writing software, but interpreting the software, modifying given software to show a proper understanding of that software without actually having to write the code. And I think that's really good, as in it will show the understanding, but not having to remember how the code is set out as such, the structure of the code. We were aware that we would have an optional unit, so if our learners did want to look into software or delve into software a wee bit more in terms of structure of code, there was a software optional unit that those pupils could go down. As Ross has already pointed out, networking was a big thing down in our area for our local employers, but also I think that is missed, especially with the way that we're working these days. The world of the internet of things, they're all networked. I think we kind of missed that networking journey in the national course. Data science was in there as well, and emerging technologies within this computing foundation course. That gives a broad basis, and people might look at that and say there was an awful lot in that, and absolutely there is, but there's not too much depth. It's more breadth to give that foundation for the pupils to be able to go into the other units. There is a bit of overlap in there depending on which units that the pupils go into, which is really good, because when they go into that optional unit, they feel that they're already they have that transitional based learning approach. Ross mentioned earlier, I know it's not in this unit, I should have picked it up, about artificial intelligence new unit. That's the first artificial intelligence unit been written across Britain, I believe. So we're certainly leading on the new artificial intelligence front in terms of course content.
So the second mandatory unit, which is the project unit, we are thinking it will come towards the end of the course and gives learners the opportunity to apply everything they've learned throughout the course in a sort of more real-life work-based project with a real focus on developing the meta skills required to be an effective team member. And so the project is completely open to depending on what optional units that the learner has completed. So if they had gone down the hardware route, the project could be building a computer. If they had gone down the networking route, it could be configuring a simple network. But all projects will involve some sort of project plan, some sort of design, an implementation of a solution, testing the solution, and then an evaluation of their contribution and the development of their meta skills. In terms of the sort of assessment and the evidence required, it's all naturally occurring evidence. So they create a project plan, the plan is the evidence. They design it, there's the evidence. So it's designed in a way that it's that it is natural and it flows, and it does have that slightly more work-based focus, which I'm personally really looking forward to delivering. Obviously working in groups, and that final outcome there, talking about their contribution, again, we wanted to focus more on learners evaluating their skills rather than the project as a whole. So certainly at level 4 and level 5, the evaluation aspect is concentrated on them and their development. Level 6, it does touch on evaluating the project as well. So that gives you a bit of a sort of introduction, broad overview of the new qualification. We don't want the conversation to stop there. Obviously, it will be published very soon, and there's probably more questions and sharing of ideas and resources and that kind of thing. So I believe Brendan has created an NPA Computing Technologies area within STACS Connected, and there is also now an NPA Computing Technologies channel on the Computing Science Scotland team, which I know both are sort of very active places. So hopefully you will be able to access one of those and keep up to date with when it's published, that sort of thing, as well as contribute your ideas and resources going forward.
Could I just jump in there, Ross, a wee second as well? There's a question down in the comments about how much do the learners have to write, describe, do, etc. we are absolutely, it's on the screen now. I think when we started to undertake this, we saw there was a need as well in terms of the National 4, current National 4. We didn't feel that it was equal to other National 4s across different subjects. So hopefully what we've done here is bring the level 4 in alignment with other subjects, level 4s. For instance, in geography, I asked them to just name capitals in certain areas, which was completely different to our National 4, our current National 4. So we kind of envisaged that solar would get used quite a bit for multiple choice type questions, Nicole. So hopefully that would help with the where you've asked about describe and evaluating the computer program project. Ross would be able to probably give you some more information on.
Yeah. So as a general rule, although not all the time, but general rule, level 4, the word used is state. Level 5 is describe, and level 6 is evaluate. So there is clear progression there. But in terms of the writing or the reporting required for the project unit, as I say, it's all naturally occurring, and it can take a variety of forms. So it's not the unit specification does not require them to write a report. It might be that they can produce evidence in another way, a poster or something like that, and that's totally acceptable. In terms of evaluating their skills, will likely that could potentially just be evaluating on a scale of saying, well, how have they developed in a particular meta skill, collaborating, for example, and maybe a sentence to justify their rating out of 10 or whatever that might be. I see a question there, will there be assessment support packs produced? My understanding is that assessment support packs will be produced for the 2 mandatory units. Some of the optional units may already have assessment support packs, some of the existing ones. I'm not sure about the new optional units. I don't think they are. Derek, if you
we're unsure whether they're going to have the aspect, as Ross has mentioned already. Some of the current ones are already there. The new ones will get assessment support packs, as far as I'm led to believe. That is in the pipeline. There's also somebody mentioning about materials for delivering this available. Well, we've hopefully, there's a number of things we can say in here. Hopefully the unit specifications give a wee bit more information than the standard unit specifications. Certainly in the computer foundations, there's a good bit of information there, or guidance on assessment and knowledge that the pupils will need to be aware of. So that those will come, and also the unit specification will hopefully have a wee bit more information. It will give a wee bit more description than it does in others.
And we're hoping that the computing science community will come together in terms of sharing resources and sharing ideas, because I'm very, very aware that we are good at that, particularly with STACS. So taking the lead on that and coordinating it with the shared drive and that sort of thing. Just having a look to see if there's any other questions that we've missed. Can you give an example of how learners can win a specific apprenticeship? So my experience of how learners get apprenticeships or are successful in getting an apprenticeship is through work experience and sort of working with employers before they're applying for an apprenticeship. It's that old saying of it's who you know, not what you know. And so we've had a number of pupils, not just in terms of computing, but just across the school, who have successfully gone on to study an apprenticeship. And generally speaking, that is because they've done work experience at school. They've done a visit as part of our DYW work. They've gone out to visit the employer and had a tour around the place, or the employer has come in as part of the subjects that they're studying. And I think that is really important. And I think this qualification offers lots of opportunity for those employers and partners to come in and work with pupils, develop those contacts, so that when they are leaving school and they're considering employment or apprenticeship, then they already are known by local employers. I think you're on mute, Debbie.
Yeah, I can't hear you, Debbie.
And I was talking away as well. So it was just me saying thank you so much for all the work that you guys have been doing. It looks like there's going to be some great opportunities coming. And on a personal note, AI is back, and I am happy because that was my favourite topic, teaching with old intermediates. So just hope that we can catch up again at another STACS event. And I've got a wee note in here from Brendan saying that maybe we could have a STACS event hosted down in Dumfries and Galloway. That would be absolutely amazing.
Yeah, that would be good.
It would be great. Right. Again, guys, thank you so much. And we're going to move on now to Tracy.
Hi, everyone. I've got the graveyard shift, haven't I?
You have.
Yeah. And I was crazy and said I'll do a live demo. So, yeah.
Good luck.
I'm going to share my screen. I've got a bit of a presentation, and then I've got a live demo, as I say. So we'll just go with this. I'm going to just share absolutely everything, and I'll put my audio on. There we go. So
good luck.
What I am going to show you, thank you. I might need it. Right, I want to present this, and I'm going to go full screen for this. There we go. So obviously I'm Tracy Mutter, and I am looking at MakeCode Arcade with you tonight. Now it's that and my wee magic meow bits that I have. So If you've not seen Make Code Arcade before, it is a free website from Microsoft. It combines making characters, because my kids love making characters, especially the girls. And they also make game screens, and then they combine that with coding. So you can play the completed games online, but we like to download them onto a compatible device, which ours are Meow-kits. So I use this website with my BGE classes. I use it with wider achievement, and I can also use it with level 4, the NPA Games Development pupils. In my school, we have risk assessed. It doesn't need a DPIA because the kids just log in with their Glow accounts. So that way it sees their progress, which is really, really useful. You might be kind of used to this kind of website because they Make Code do the Microbits website, but this one focuses on kind of retro arcade games development. So it looks fairly similar to most online coding things. So you've got your emulator where you can see the results, your toolbox, and a window in which you code in. Okay, I really like this in that it has different coding modes. So we begin with the block tutorial. So some of the kids will have done Scratch in primary school. They're kind of used to that. But we can then switch them either into JavaScript or Python. And you can actually, while you're in coding, switch it between the languages just so that they can see the differences. When you're creating your own projects, you can actually pick what you want to code in. Whether you want to go something with all three and you can switch between the two, or whether you just want Python only, or whether you want JavaScript only. So from this, I am now on, just checking my slides, right, so I've got one more. So this is my Meow-bit. This is my actual one that I have plugged into my computer tonight. So this is what we download our games onto. It does actually support lots of different devices, and I'll give you a quick swatch at those when we're in there. So our kids absolutely love these, and I think they would just put them in their pockets and take them home if they could. Lots of them actually said to me at Christmas time they were going to put them on their Santa lists. So that's how much the kids really like this. Okay, so that's my presentation. There is a whole bunch of videos in there that I can share that with you later. So this is the Make Code website. I'm signed in. You can see my wee glow thing. Up the top here is where my projects are. Now you can see this one is green, 5 out of 5, because I finished that tutorial. This one, I deliberately didn't finish it, so you can see it's 2 out of 10. I haven't finished that one. Okay, so all the ones that you've done are up here. When I use this with my BGE classes, we always start with a beginner skill map. You can see in this one, like Whack-the-Mole, it is just a kind of, you work through it. Wait till it loads and then I'll show you. So it gives you kind of tutorials, you work through each one. So we start with this one. When I complete that one, I unlock the next level and you get all the way up until you get a certificate. So quite gamified, and the kids really like that, particularly the BGE ones. They get a certificate at the end. They all leave computing with a certificate that they can take home, and they absolutely love it. So we start off with the beginner skill map. It kind of introduces them to the website and what it's all about. Then we come into the tutorials. Now we do Chase the Pizza. Now this one is about chasing and catching something. Obviously, we let them pick. You don't have to be a pizza. You don't have to be a smiley face, and you don't need a green background. We do that one. We do Time Flies, and this one is trying to stop the fly when it touches your frog. So it builds up different skills in the kids. And then the last one that we do with them is Galga, and that's a shooting game. And it has projectiles and it has baddies in it and it has high scores and all that kind of thing. So once we've done that, we actually get the kids then to go through a design. So we give them a brief, which is the analysis bit. They have to come up with a design for their computer game, and then they go and implement it. They test it. We download it onto the Meow-bits, and that gives them their evaluation and their feedback. So introducing the waterfall method. Now, while I'm on here, there are hundreds of different things on this website that you can do. But I'm going to try and build a game before 8:30. So I'm going to go for a new project, and I'm going to call this one Duck Escape. I can't spell duck, so there we go. So I'm going to create that. Now, I've created this blocks, JavaScript, and Python. I can do the whole lot in it. Now, when I started using this, I actually thought the backgrounds were all the ones that were just in in the scenes. I didn't think there was anything extra. So I thought the background images were all just these. Now, if I pop that in and go here, you can see that this is where we like to create. Now, the girls really enjoy drawing things in here, but there is a gallery. And I used to think that that was all the backgrounds that there were until I discovered something else. So I then discovered that if I came down here, there was a tile map. So I can create a tile map. Now, when I create this, there are all different kinds of lands that you can create. So forest, aquatic, dungeons, and miscellaneous. So what I'm going to do is I'm just going to start putting some stuff. Now, to do this, I'm just clicking and dragging with my mouse. Nothing fancy about it. Okay, and I'm going to make a kind of maze that I want my character to run around in. Okay, and then I'm going to put in some ground. This bit, we don't tend to show the kids until they're well into this, because if you show them this, they will actually just sit and play around with their wee tile map for hours and hours and hours. I've had kids in my room at lunch times, intervals, and after school, everything, just mucking about with their tile maps because they want it to be perfect and they want theirs to be the best in the class and what have you. So regularly I have a classroom full of BGE kids all mucking about with their tile maps. There are pages and pages of these things, that there are lots and lots of different things that you can have. And I want one of these, and I'm just going to stick this down here. So that will be my exit thing. Now, at the moment, if I stick this back in my world, I can actually just saunter straight through the walls, and I want to stop that. So I'm going to click on this, which creates walls, and I'm going to colour these bits back in, and this is going to be my wall. So I now cannot go through this. My wee character will just stop. It actually won't go through there at all. So I'm just going to quickly just whiz through the rest of it, and that's going to be my tile map. Very, very simple for tonight, and I'm just going to click done. So this will now render on here. I will have a black background behind my trees. Oh, my trees are actually not so bad tonight. So sometimes, depending on what you pick for your trees, you get a black background, and sometimes you'll need to go in and then set your background colour to green just to hide them. Okay, so what I want to do now is I need to get a character out. So I'm going to go into my sprites, and I'm going to get my sprite. Now, you can change this. So if you want to talk about renaming variables and what a variable is, you can absolutely do that. I don't have time tonight, so I'm not going to bother. In here, again, you can draw your character, or you can just pick one out. Now, I said this was Duck Escape. There are lots and lots of characters in here as well, but I'm just going to go with a duck. So that's me got my duck, and this one is a kind player. Now, I don't want my duck starting here. I want to actually start my way up here. So on my tile map, I forgot to put that on. So I'm just going to put this thing up here, and that's what I'm going to say I'm going to start on. Okay. So in my scene, I need to come down then, and I want to place my duck. Where did you go? Right, I'm going to place my sprite on top of a random what? And you can only pick whatever in there. Now, I only put one of these on, so pick random one of one. It will only pick that one. Okay, so there's my duck now in the corner. Now what I want to be able to do is actually move my duck around. So I'm going to go into the controls and then move my sprite with buttons. Obviously, if I had called this duck, I would need to change it all the time. Okay, all the way through, obviously. Okay, now, if I try this now, you can see that the duck will move, but it's just wandered off the screen. So now I need to get the camera just to follow my duck all the time. Okay, so again, I'm scrolling down, so camera follow my sprite, so that when I do that next time, it will actually just go down with my duck. Okay, so you can see that it actually just follows me. Okay. You can start countdowns and have timers and all those kind of things as well in this. If you wanted to play it against the clock, that would be absolutely fine. Now what I'm going to do is I'm just going to add in an enemy. So I'm going to have another sprite, and this time I'm going to pull in another one. And this time I'm just going to change this to an enemy. Now you can see that there's food things that you would be collecting, projectiles are things that you're shooting, or you can add and rename different things in there as well. So again, I'm just going to get another sprite. I'm not going to draw one. I'm just going to grab something out of here that would be chasing a duck, and I'm just going to go with this wee dude. So that's me got an enemy. Now I need to place it on top of somewhere as well. So again, I'm going to go back into my scene and I'm going to get my place. Same as I did before, I'm still getting my sprite and I'm going to put it on top of a random something else. Now this time I'm going to put it on top of a random kind of middle block so that it will just appear somewhere on that screen. Oh, I actually moved my sprite too. There we go. I forgot to change the variable name. So there we go. So somewhere in there is my enemy, but I don't know where they are at the moment. Okay, so what I need to deal with now is, what if I come across that during the game? I want to lose the game. Okay, so I'm going to come into sprites, and in here I'm going to go with all the way down. And there's a section for overlap. So what happens if you overlap? Okay, so I've got, if sprite of kind player overlaps with another sprite of kind enemy, then what I want to do is go into the game, and this is going to be game over because it's just going to kill me if I've touched that other sprite. Okay, so that would be game over. Right, the other thing that I did, I placed a chest down the bottom, and that is what I'm trying to get out of that and win the game. So again, I need to have another overlap, and this time it's going to be if I'm touching that thing, then I can win the game. So again, I'm going to scoot down until I get to my overlaps. And this time, oh, that's that location, it's not that, bin that. So on sprite kind player overlaps at, right, okay. I want to change that for a location. I don't want that to be there. But where did it go? The joys of doing a live and trying to be quick because I know I'm running out of time. Right, so because I want to have a game win if I manage to overlap. So I wonder if I can do. No, because it's not another. Deary me, it's totally disappeared. Right. What I am going to do is, because I do actually have this whole game made, and I'm just going to open it. So I'll just open this one because I did have it last night when I looked at it then. Okay, so what I had done is I had created my map, and I've got all this here. And this is exactly the same way. And you can see that I had started changing it to my duck. I had renamed the variables. So the bit that we were missing here was on sprite kind player overlaps with that box that I had put in. This one I had also put in a timer. I didn't think I would have time for a timer tonight, but there is your timer. They come from the info section where you would get your scores and things like that. You get that in there. Okay, so now that I have my game built, what I then need to do is actually test it. So over here, I can actually go full screen, and I'm just going to refresh it, and then I'm going to start moving. Now this map is slightly different than the one that I had built with you. Oh, there's my wee guy. Try not to jump into it, and my map is way over there. Okay, so that is the kind of thing that you can do with the kids. There is actually a tutorial in Arcade to do this, but I like to just actually build this with the kids so that we're building it up and they can see all the different bits and pieces rather than just letting them work through a tutorial on their own. Once we've got that, what I then need to do is to download it onto my Meow-bit. Now, I'm going to try and show you my Meow-bit because I know I'm sharing full screen, which will be quite hard. So I have a Meow-bit. I'm just going to show you how to download that onto it. So I've got my device and I've connected it to the computer. It's just got a cable into the top of it and a USB cable into my computer. When you switch it on after that, it comes in a kind of F4 mode, and I'm going to click the 3 dots to then open up some more options. Now, I don't want to download it as a file. I actually need to choose the hardware I'm going to download it onto to begin with. Now, obviously, I have a Meow-kit, which is this first one, but if you have a quick look at the other things that it does support, actually, oh, my computer's frozen now. Oh, there we go. Right, so it's kind of going down. So there are lots of them to choose from. It will kind of reload itself and it will save. Obviously, it's then saving it for preparation to download onto a Meow-kit. What I'm then going to do is normally you have to connect it. So because I've connected this one to my computer before, I'm just going to disconnect so that you can actually see what happens here. Okay, so I've picked my hardware. Oh, it didn't connect. Okay, so normally you connect and you have to pick it out with a wee pop-up window. You pick your Meow-bit and it'll connect to it, and then finally you can download. Now, what will happen with this is that it will just download in the background and it will just go straight on to the Meow-bit. There isn't anything else I need to do. I don't need to grab the file and drag it over. I don't need to do any of that thing. So you can see at the moment that's it downloading. Okay, so I'm going to say done. And I already have it on my Meow-bit. It did download the file in the background as well. So if I wanted to save that on my computer, I could. But I actually have it on my Meow-bit at the moment. So what I'm going to do then, I'm going to come back out of this because that would be a really quick whirlwind stop of how you make a game in MakeCode Arcade. It's quite similar to Scratch in terms of it's the blocks and things. What I didn't show you actually was switching between the different languages. Now, I quite like to do this with, actually the last lot of kids that I've done this with, it's actually been the girls, because they've been quite interested in taking this a bit further and saying, well, what does it look like if it's in a different language? So, and I've talked to them about, we do Python when we're further up the school. So if I click onto Python, I can then just actually, it just takes it into that. So what I'm saying, can you figure out where this was? Can you follow it through? And, you know, it kind of goes from line 15 here down to line 32. Well, why is that? Can they think of why that would be? And when we open it up, well, that's your sprite, that's your duck that's in there. So you can switch it in between the different languages, and you can switch it back to JavaScript. And then they'll say, well, why don't you teach JavaScript? I just don't teach JavaScript, I teach Python. That's what we do in my school. But it's really nice to see the different languages and swap them in and out. As I say, normally it's the girls in S1 and S2 who actually then start, what does it really look like? What does that code actually look like? If it's not blocks, then what does that look like? So they're usually quite interested in that. And as I say, I usually have a room full of kids up trying to play with these things. Now, what I want to do is actually just kind of stop sharing my screen so that I can show you my Meow-bit. So I'll maybe, if I come back to this bit and stop sharing, it's not going to let me do it from there. Stop screen. Right, so this is my Meow-bit. Now, if I hold it in front of me, or if I hold it in front of a sheet of paper, this is my Meow-bit that I've got. And it already has got my game on it. Now, I did have a video of this. Actually, I'm not sure whether I should just show you the video or whether I should just try and show you the screen. So if I come back, it's so this has actually got my game on it. So I think I'll maybe just quickly show you back into that. Now, if I scoot along to the end, oh no, I can't, because I need to then share my screen again. I do have a video of it working. I'm just conscious of time that I'm probably about to run out of time and be hauled back off. So yeah, that's my Meow bit, and they are really, really good fun. Kids really enjoy using these. We got these with our money from the government. We bought 2 class sets of these. You could get away with less than that because the I don't have all the kids on them at once because they all finish their programs at different times. So one week, you know, you've maybe got 5 or 6 that have finished and managed to do that in time and download them onto the Meow bit. And then some weeks you've only maybe got 1 or 2, depending on what they're working on. But they are really, really fantastic, really good fun. And the MakeCode website, the kids really, really enjoy doing that. And as I say, I've got lots of kids up during the breaks and all that. And they're going to lots of them enter their competitions with the dress code arcade things. So I've got kids up working at the moment for that as well. So yeah, it's really good fun and the kids really enjoy it. There is lots of code, but they're actually all color coded. So like they are in Scratch, they are all color coded. When they work through the tutorials, they are really, really cool. Actually, I might just go and share that again because the tutorials actually are so good. If I'll go back into the tutorial that I had, because in that one, it'll just take me back to where I had been. So the tutorials work exactly all the same way. Oh, that's not sharing my screen, is it? Yeah, should be. There we go. Right, so this is what the tutorial looks like. So you can see that there are instructions at the top left. You mean in the Python? Yeah, it is a lot of code in the Python. So I like to switch it out from the text-based into the Python, but if they're doing one of the tutorials that is just Python, it's not code that's that size. The tutorials, as I say, they've got, you can see how many you're going through here. It is quite text-based, but there is immersive reader built into it, so it's really supportive for weaker learners, but it has this magic light bulb at the bottom that shows you what you need to put in to make your code work for that bit, and then you're clicking next. The instructions change, and you can actually just click on these and it'll open them up for them. So it's really, really easy to get to grips with in the tutorials as well. But as I say, if you're doing a tutorial for Python, it's not like that huge big long code that I showed you when I had made a whole game and then switched it in. It's not usually as extensive as that. So I'm going to stop sharing again. And how much the Meow bits? So they're £50 each. We got them from Amazon. I didn't actually buy them directly from Kit and Bot, but you can. If you're buying them from Amazon, the only thing I would say is make sure you either get ones that have batteries in the back of them, because the battery just goes in the back section here. But you can actually get replacement batteries off the Cartronic website that are only about £3 or £4 each. So yeah, you might be able to get them cheaper and then just buy the cheap batteries for them. So they work too, but they're fab and the kids love them.
Right, thanks so much, Tracy. That was absolutely brilliant. And I love the bit that you're commenting that the girls are the ones that are looking at the code. That is fantastic.
Yeah,
anything
more them than the voice.
Aye. Anything that helps to close the gender gap, you know that we're all about that. That's on our priority list. And I agree, when you use the MakeCode, I don't have the wee Meow bits, but when you use it, the girls are the ones that seem to want to go and do the JavaScript or do the Python.
Mm-hmm.
Yep. Right. So everybody, thank you so much for all your questions tonight. And Tracy, again, thank you so much for that fabulous presentation. And you're so brave trying to do a live demonstration. I did not do that last night. And guys, that brings us to the end of day 3 and the end of the festival 2024. It's been a fantastic 3 days. I would just like to apologise on behalf of everybody for the sound issues that we had tonight. Please don't forget to sign up to connected.stacs.scot to join in with all the CS community that's been getting set up. And you know that the videos will all be available on the STACS website. So please go and sign up if you haven't already at stacs.scot. And again, good night. Thank you so much. And I hope everybody has a fantastic and well-earned summer. Take care, everybody.